Hey guys, Mr. Yeisley here. So we're on to lesson number 5 in chapter F about fractions. So lesson number 5 is all about how to convert a decimal to a fraction. So really kind of a 3-step approach to this, what we're going through. So step 1 on this is we're going to make the denominator. So we're going to make the denominator, all right, a power of 10. So a denominator is going to become a power of 10. And as we learned about in our last chapter, chapter D, a power of 10 are numbers like 10, 100, 1,000, so on and so forth. Well, how we figure that out is by the amount of place values. So remember that place value chart you have in your chapter D notes, where we've got tenths, hundredths, thousandths. So whatever that number is, if it's tenths, you're going to have a 10 for your denominator. If it's hundredths, you're going to have 100 for your denominator. If it's thousandths, you're going to have a 1,000 for your denominator to begin with. So that's how we figure out the power of 10 that we have to use. And this is, again, as we talked about, based on the place value of the original decimal. So what are the place values that it goes to? Right? Second thing we need to do is we're going to drop the decimal then, right? Get rid of the decimal point, and we're going to put the number in the numerator of the fraction. So we've created our denominator using the power of 10 based on the place value, right? Then we are going to get rid of the decimal point, and we are going to put the number that we have left in the denominator, or excuse me, in the numerator of the fraction. And then last thing we have to do is we need to reduce the fraction if possible, because sometimes we end up with unsimplified fractions. So we need to reduce the fraction if it's possible. And we've learned how to reduce fractions in a previous lesson. All right, so we've got about 5 examples here that we're going to go through, because this can be a little bit tricky at times, so we want to make sure that we've got a good explanation on it. So example A says 0.67 or 67 hundredths, right? Well, again, first thing I need to do is create my denominator of my fraction, and it needs to be a power of 10. Well, this is based on the place value of the original decimal. So I see that there are 2 place values, and that is the tenths, hundredths, right? Well, that power of 10 would be 100. So here we go. I need 100 on my denominator. Then second thing, I'm going to get rid of my decimal point, so get rid of that, and I'm going to take the number that's left, which is 67, and I'm going to place that into the numerator, so 67 over 100. Last step, I need to reduce the fraction if possible. So here's where we're going through those lists again and figuring out, right, are there any factors that they have in common that are larger than 1, right, and what's the biggest one that they have in common? Well, on this one, 67's only factors are 1 and 67. There are no other factors of this. 2 doesn't work because it's not an even number to end with. 3 doesn't work because 6 and 7 is 13. That's not a multiple of 3. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. So on and so forth. So once I've figured out that, all right, I know that this cannot be reduced any farther, so it is as simple as it is going to get. All right, so let's take a look at example B then. So first things first, I need to make the denominator a power of 10 based on the place value of the original decimal. Well, I see that we have 2 place values to the right, so again, I should have a denominator of 100. Now I need to get rid of this decimal, all right? Well, anytime you have a 0 to the left of the decimal point, and that's all you have, you can also get rid of that, because 0.95 is the same as just 95. So now I've got that placed into the numerator of the fraction. Last thing I need to check, can I reduce the fraction? All right. Well, I can list out all of the numbers that I know go into it, but a quick one that I see right now right off the beginning is that they end in a 5 and they end in a 0. So that means that they are divisible by 5. So if I don't want to check for all the factors, I'm just going to check divide by the one that I know, and then I'll do a quick check again after that to see if they have a factor in common. So I'm going to divide by 5, divide by 5. Well, 95 divided by 5 goes in once to 9, then carry the 4, 45. 5 goes into 45 19 times, and then 9 times, which makes a number of 19, excuse me. And then 100 divided by 5 is 20. Well, 19/20, those numbers are right next to each other, which means they cannot have a number other than 1 in common. So that is my final simplified fraction of 19/20. And let me move this up a little bit. Had that cut off just barely at the bottom. All right. So again, if you aren't sure but you know one factor, just divide by that factor and then check it again at the end. And so we're not always going to know those numbers off the top of our head. All right, so example C, let's try that one out. So first things first, got to figure out my denominator of this fraction. Well, I see I have 1, 2, 3 decimal places this time. Well, that's tenths, hundredths, thousandths. So 1,000 is my decimal place, or is my denominator, excuse me. Can't speak today. All right, once I have my denominator, now I need to get rid of the decimal, and any zeros to the left that don't have a number beside them, I can get rid of those. So I can get rid of both of these zeros, and all I'm left with is 56, and that becomes my numerator. Now I could write 0056, but there's no need to, right? I'm just gonna write 56. All right, now I need to check and see, do they have a factor in common greater than 1? Well, you may look at this and go, I don't know, those are two pretty far apart numbers. Well, just an easy one to check for always is, are they both even numbers? If they're both even numbers, divide by 2 and see where that gets you. Well, I see that they are both even numbers because it ends in 6 and ends in 0. So I'm just going to divide by 2 on both of these and see where that gets me. So 5 divided by 2, that's 2. Carry the 1 that's left over, 16. 16 divided by 2 is 8, and that's an even number. And then I've got 1,000 divided by 2. Well, I know that's 500. Well, that got me reduced down some, but I see that both of these numbers are still even. Well, that means that there was a number that was bigger than 2 that could go into it. But that's okay, all right? Even though I didn't find it to begin with, I know that I can now see that they're both even numbers, and I can divide by 2 again. So let's divide them both by 2 again and see where that gets us. So 28 divided by 2, I know that off the top of my head, that's 14. And then 500 divided by 2, that's 250. All right, well, you may be looking at this going, hey, those are even numbers again. That's okay. Even if we don't figure out the largest factor to begin with, we can still keep reducing until it's not possible to reduce any farther. So I see that 14 and 250 are both even numbers again, so I'm just going to divide by 2 again. So 14 divided by 2, that is 7. Let me make sure this is still in the picture, and we're not. There we go. Sorry about that. And then 250 divided by 2, I know that that is 125. All right. Well, when I look at that, I know both of those aren't even numbers. All right, 7, the only factors of it are 1 and 7. So unless 7 goes into 125, which it doesn't, there are no more factors left. So here is my most simple form of that fraction. So anytime you've had to reduce a bunch, again, that just means that there was a bigger number out there that we could have divided by to begin with. Now, if I wanted to figure out what that was, I just simply multiply the numbers times each other. So 2 times 2 was 4, times 2 is 8. So if I had divided by 8 at the beginning, that would have gotten me down to 7 over 125 right from the beginning. But I didn't know that 8 was a factor of both of those. I knew it was a factor of 56, but I didn't know it was a factor of 1,000. So it's okay. I just kept dividing by 2 until I got there, and that's completely fine. All right. Well, now I would encourage you to try example D on your own. It's a little bit different, but it's still the same process. So when I look at example D, I notice that there is now numbers to the left of the decimal. That doesn't change our process, all right? Our first denominator is still going to be the place values of the original decimal, which was 1, 2, 3. So that is tenths, hundredths, thousandths, so 1,000 on the bottom of our fraction. The top, we just get rid of this decimal, and so my top number is 12342, or 12,342. All right, and that's completely fine. This is again known as a improper fraction, and you can have those. That's completely fine. We don't even need to turn this into a mixed number. We can just simply check, are we able to reduce this? All right, well, these are some pretty big numbers, and I don't really know the factors of them off the top of my head, but I do see this ends in 2 and this ends in 0. So I'm going to start just like I did in example C, and I'm going to divide by 2 and see where that gets me. All right, well, I've got 12,342 divided by 2, so let's just start it. If you're not sure, throw it into the house up here. All right, 12342 divided by 2. Well, 2 doesn't go into 1, but 2 does go into 12 6 times. Minus 12, get 0, bring down the 3. 2 goes into 3 1 time. 3 minus 2, that's 1. Bring down the 4. So I got 2 into 4, that's 7 times, and that's 14. So 0, bring down the 2. And then, I'm running myself out of room, 2 into 2, 1 time. So I figured out that 2 goes in there 6,171 times. Well, I remember from last one, 2 goes into 1,500 times. So now I'm at this point, and I'm looking at this going, hey, are there any other factors that go into this? Well, if it ends in 1 and ends in 0, odds are they do not have another common factor, which this one does not, because ending in 1 almost always, not always, but most of the time means that it's going to be a prime number. But not always, like 21 is not a prime number. But 31, 41, those are prime numbers. So you could just quickly check those and make sure, but this is the simplified form of this fraction. So final answer, 6,171 over 500, or 6,171 500ths. All right, I'd encourage you to try example E on your own, and then check your answer with mine. So first things first, got to figure out what's on the bottom of this. Well, 1, 2, 3, 4 decimal places. So that means tenths, hundredths, thousandths, 10,000ths. So right there, I've got 10,000 on the bottom of my fraction, right? And then the top number, get rid of the decimal, and I've got 42095. All right, we may be looking at this going, again, I don't know what the factors they have in common are. Well, check for those easy ones. Use those tricks we learned about. So they're not both even numbers, but I do see that one ends in 5 and one ends in 0, which means they are both divisible by 5. So I'm just going to divide them by 5 and see where that gets me. So again, I don't know these off the top of my head, so I'm going to throw it into the house method up here. So 42095 divided by 5. So 5 doesn't go into 4, but it goes into 42 8 times. 8 times 5 is 40. Got 2 remaining, bring down the 0. So 5 goes into 24 times. 5 times 4 is 20, so nothing remaining, bring down the 9. 5 goes into 9 1 time. Subtract 5, that's 4, bring down the remaining 5. 5 goes into 45 9 times, and that means I have no remainder. So top of my fraction is 8,419. Bottom of my fraction, 10,000 divided by 5, that is 2,000. All right, well now when I'm looking at this, I'm going ends in 19. Is there any factors that I could check? I do a quick check of them. 2 doesn't go in, 3 doesn't go in, because when I add those, not a multiple of 3. 4 doesn't go in, because these last 2 aren't divisible by 4. 5 doesn't go in, because it ends in 9. 6 doesn't go in, because 2 and 3 weren't factors. 7 doesn't go in. 8 doesn't go in, 9 doesn't go in, because add them, they're not a multiple. 9 doesn't end in 0, so 10 doesn't go in. So none of those are factors, so that means that this is the simplest form of our fraction. So as you can see, sometimes these numbers can get pretty big. But if we just use those little tricks that we talked about in the very first lesson, we can get to where we need to, even if we have to do it multiple times like we did on example C. All right, well, you should have everything you need at this juncture to continue on in the playlist. If you have any questions, please let me know.